Hi everyone, my name is Naama Schwartzblat. I'm the product manager of this integration with the Conjur and OpenShift, and together with the Kumbi. Kumbi, you want to introduce yourself?
Yeah, sure. So I'm Kumbirai Tanekha. I'm a software engineer at Conjur. In some regard, I'm responsible for implementing this OpenShift integration, and looking forward to sharing it with you all.
Great. So can you move to the next slide, Kumbi, please?
Sure, yep.
Thank you.
Naama, can you see it?
Starting, but it's very slow, but yes, it's coming. So because I'm going to share some roadmap with you also on this integration, this is a RevRec slide that saying that things might change a little if on things that I will share with you regarding the roadmap. So just take this into account. So I want to share some information regarding CyberArk. What is CyberArk? Who is CyberArk? So we are a market leader in the area of privileged account security, protecting the heart of the enterprise against advanced attacks of cyber. We are the second largest Israeli cybersecurity company in the world, and we have a proven successful continuous innovations with award-winning enterprise-class solutions. Next slide. And I want to talk a little bit about what is Conjur. So Conjur, we acquired Conjur about a year ago. Conjur is a company that was started in order to secure the old new modern environments of DevOps, cloud, and containers. It's a secret management solution, addressed all the privileged security for those environments, for the new environments, with the native integrations, with cloud management and DevOps orchestration solutions, as well as containers. They are focused on security, and as Diane mentioned, we do have also an open source version of the product for developers. And now I want to share information regarding the integration that we just released with OpenShift, Conjur and OpenShift. So first of all, when we were talking about securing application containers running inside all those containerized platforms, we understood that the popular methods for providing the secrets to the containers are either using environment variables, using volume mount, or just secret encryption. And the challenges there were that secrets can be easily exposed. There's no runtime authentication to understand that the calling pod or container is really your application container or pod and not just a malicious one. There's lack of segregation of duties, and there's no audit for all the things, all the security and the secrets fetching. So our integration goals and benefits that we wanted to achieve with this integration in this area were, first of all, to securely provide the secrets to the application containers that are running in those environments like OpenShift. We wanted the integration to be easy to use. We wanted it to be seamlessly as possible, so developers will not need to change their application code in order to use and fetch the secrets securely. And of course, we wanted to provide strong authentication for the calling containers or pods based on the properties, and for that we wanted also to leverage existing APIs of the platform of OpenShift or Kubernetes in order to verify the identity of the calling pod or container. We wanted also our solution to run inside OpenShift because we wanted it to be elastic and that it will be able to scale out very easily, because the number of containers can change and we can have massive amount of containers starting. And also running on the same physical host means better performance, of course, and we can gain from that. We also wanted to provide, of course, central audit and secret rotation options. Next slide. So here are some milestones and roadmap plans that we have for that. So first of all, we had an OpenShift integration beta that was done in June, a very successful beta. and we now just released a generic version with using OpenShift 3.3 and up. The reason we are supporting older version of OpenShift is because we have customers that are waiting for those versions and wanted the solution to work the same for their environments as well. And that is why we started with a generic solution that can fit all versions of OpenShift from version 3.3 and up. And so this is the generic solution that we are going to share with you today. We are going to release also a Kubernetes integration early Q2, early this quarter. And the next steps that we are planning, again, in the near future is, first of all, we are going to add more capabilities for the authentication to increase also the strategy of the authentication of the pods. This is one thing. We are going to add more flows that exist only in newer versions, like the init container option that we had also in the beta, but does not exist in OpenShift 3.3. We are going to add those flows in the next versions that we will add into the OpenShift integration with Conjur. And we are going to look also on newer things like the service broker that was just released lately and more. Kumbi, I will hand it to you now for the next slide.
Thank you, Naama. Okay, so I'm going to speak about the components of the integration a little bit, and then eventually make my way towards giving a demo of this integration in action. So quickly, I'll just go through what things look like from the Conjur side of things, and then how these components look from the, I guess, application side of things. So applications will be consuming Conjur in order for them to get access to the secrets they need, and they'll be using their own identity in order to authenticate against Conjur. So Conjur, as Naama mentioned earlier, is a secret management solution that provides authentication, authorization, and all that sort of stuff, right? So from an authorization standpoint, the kind of permissions model that we have is based around policy, right? So it's a declarative policy that allows you to say who has access to what. It's role-based access control. And taking a step back and looking at the architecture of Conjur, so what we have is we have a high availability architecture where we have masters, standbys, and followers. And in particular, for this integration, you can essentially have the whole Conjur cluster running within OpenShift, and that's what's shown on the right-hand side here. So there's a Conjur master, some standbys, and followers. And followers are for the purposes of read-only, right? It's for consuming the secrets as opposed to anything else. And the authenticator that we have that leverages the OpenShift API in order to verify identities of workloads running within OpenShift runs on a Conjur follower, right? So how the whole architecture works from the standpoint of the actual application is the application is running in its own project. Conjur runs in a specific project of its own, the whole cluster, even though the different kind of like entities within the Conjur cluster could be running on different nodes, and they probably should. The application speaks specifically to Conjur followers. So you might have several followers, and these might be part of a deployment within OpenShift. How the applications speak to the followers is through a service, right? So there's some load balancing there. An application doesn't really necessarily need to know which follower it's speaking to. It just speaks to some follower. Great. And from the application standpoint, how we have it laid out is a typical application is within a pod, and there's the main app container, and that app container is responsible for actually running the application. We have a sidecar we're using a sidecar pattern as a means of actually like orchestrating this whole communication to Conjur, right? So that ultimately the app container doesn't really need to know too much about like authenticating against Conjur. All it needs to do is essentially consume an access token and grab its secrets. Right. Moving forward. So the high-level steps of the actual process of like authenticating against our integration is we have to verify that a pod exists, and essentially what we're doing there is authenticating the pod, right? We know the pod is indeed who it says it is, and then once that's done, we go through the whole process of like authorization using our RBAC model, and auditing and all that sort of stuff just kind of happens in the background. This is kind of part and parcel of Conjur, right? Right. So the flow, like kind of diving deep down a little bit, comes in the form of the sidecar kind of negotiates this whole authentication that I spoke about before. And more concretely, what's actually happening is the sidecar will issue a certificate signing request against the Conjur Authenticator. And within that certificate signing request, it will provide relevant details. And the Conjur Authenticator will validate this certificate signing request. And if everything checks out, it will issue a signed certificate out of band and actually inject it directly into the sidecar container, right? So this is where we get like a kind of like some strong security, because the signed certificate goes specifically to the requesting pod and nowhere else. Once that signed certificate is actually available within the sidecar container, then the sidecar container can then make a request through mutual TLS once again to the Conjur Authenticator. And what happens is the sidecar container gets an access token for the particular identity that it's signed up for. And this access token is encrypted, and obviously the sidecar has the private key in order to decrypt that particular access token. And once it has this access token, it's really just back to secret management as usual with Conjur, because if you have an access token, it means you can authorize, get your secret, you can be audited, because whenever you access a secret, we know who's accessing the secret, right? And essentially the application can start at that point. So we actually have a tool called Summon, which is open source and can use a variety of secret providers. But in this context, it would be using Conjur. And what it would do is it would make use of the information available in the environment, and also this access token, which is within the shared storage. And it would grab the relevant secrets for the application, make those available in environment variables or through other means to the main process of your application. And essentially your application can go along as usual with all the secrets that it needs. Yeah. So that's the flow on a very like a little bit detailed level. Right, so I would actually like to show this working within an OpenShift cluster that we have running within AWS. So I'm gonna move over to demo time. Right, so I've set things up already just in the interest of like, you know, the demo demons aren't great, or rather the demo gods aren't always kind. So I already have a Conjur cluster set up. And this Conjur cluster has a master here. It has 2 standbys, and it has 2 followers, and that's what these are. We have some kind of like a load balancer in front, but in any case, these are the followers that I was speaking about. And the load balancer is what the application actually speaks to. So I'm gonna take a second and head over here to my IDE. So the process of actually kind of like setting up this whole integration is first you have to deploy Conjur. And instead of like going through every single one of these scripts, I'm just going to go through it on a very like high level. This is something that's available on GitHub, like both of these repositories. So this is something that could be reproduced, I suppose, by anyone. So the first step is for us to create an OpenShift project from a Conjur deployment standpoint. And this is the project that I spoke about earlier that essentially kind of scopes Conjur within it, right? So before I run all these scripts, I actually have to specify all these environment variables, which are like the Conjur project name. And if I head over here where this project actually is being run, so I have my OpenShift client already set up. And if I head over to that project and we list the pods here, you will see that I'm not really making this up. There are actually pods in there. So we have some followers, and we have some of the members of the cluster, standby, master, etc. So when you run these scripts here, you create the OpenShift project, you build and push the relevant kind of container images. And our recommendation is to do that with like a private registry within OpenShift. Like that's very good for that. You deploy the Conjur cluster, and this is just, you know, running your manifest as normal. You configure the master, you create a load balancer, configure your standby, configure your followers. These are very straightforward steps that you know, you could go into detail if you're actually trying to set up a Conjur cluster. Where things get interesting is once you've got your cluster set up, how do you then start interacting with that with an OpenShift application, right? So this is where this repository then comes in, which is OpenShift Conjur demo, and it makes use of, I guess, similar environment variables. Once again, it needs to know the Conjur project name in order for it to be able to generate the URL, etc. So we initialize Conjur, which just makes sure that, you know, we're able to log in. So we have admin credentials, which allows us to run all the policy and load all the policy that we need to. We go to the second step, we load some policy, and this is just the workflow from a Conjur standpoint, right? We have a CLI that allows you to load policy. The policy is in YAML. So you just run Conjur load policy with the particular YAML file, which I can show over here. And actually, I'm going to dive into one of these just for a moment to show what's happening. So I'd spoken earlier about like a certificate being signed, right? So what's actually happening internally is we have a CA for each, I suppose, OpenShift cluster, and the responsibility of that CA is to sign like valid workflow identities, and then those identities can kind of be used by applications in order to authenticate. Each application is represented by a particular host, and this is what's happening right here. So the host in this example takes the form of like the namespace, or rather the project, followed by these wildcards, which essentially say that we're scoping identity to the namespace. So any application within a namespace can assume this identity, and we use the OpenShift API in order to verify that a workload or a pod is actually part of a particular namespace, right? Or a project, right? So once we've actually initialized Conjur, we load some policies, and that's one of the policies that I was just speaking about. So this policy is what allows kind of RBAC to be respected, right? We specify in here that this host is actually part of a particular grouping of other hosts, and we specify permissions over here, where we say that this particular application can read this test app database password. It has read and execute privileges on it. And this is what happens throughout the course of authorization. So going back to those scripts that I was speaking about earlier. So we go through the process of essentially setting up the test app project. We've run the policy against Conjurer already. We create the test app project. We build and push containers for the test app image. And then ultimately we deploy the test app. So I'm actually going to redeploy that test app so that you can just see it kind of working from scratch. So how that would look is going to run this, and this should be completely idempotent. Like it will create some a Docker pull secret, which is responsible for making sure that OpenShift can actually pull down the image from the private registry within OpenShift. And this will just take a moment to run. While that runs, we should be able to see that over here, this test app should disappear in a moment because the project will actually get deleted. Right, okay, so maybe that happened all too fast. But in any case, what I can do now is I can head over to the URL for the OpenShift dashboard. And that will be the first step. So if you just give me a moment. Right, so I'm going to go ahead and run this, which should spit out the link to the Conjur cluster, right? So I can head over to the Conjur UI and just show what's happening in the Conjur UI, but I can also show the OpenShift dashboard. Right, so I'm in the OpenShift dashboard, and I was showing everything in Weave Scope earlier, but you can actually see that everything is running within the OpenShift dashboard. We have a deployment for the Conjur cluster and the follower, et cetera, but we're not interested in that. We're interested in the test app. So here's the test application. There's one instance running. I'd mentioned earlier that there's a sidecar associated with deployment of test app. And you can actually see that from the manifest for test app, which is available here. So let's just go down a little bit. So this is just a deployment for test app. Test app is a really simple Ruby application. It has these environment variables kind of tell it how to communicate with the Conjur cluster. And it has that volume mount that I spoke about earlier for the Conjur access token. And then the Sidecar Authenticator that I spoke about is right here. So it uses an image that's publicly available on Docker Hub. And it essentially just plays the role of authenticating. And the application, what it actually does, if we dive into that for a moment, is it is a really simple server. It uses the Conjur Ruby API in order to retrieve this variable. I showed this variable a little bit earlier in the Conjur policy, right? So this will be using the identity of, I guess, the namespace in order to grab the secret, and rightfully it will get it. So if I head back here, we know that there's one pod. What I can do is I can actually access this pod, but before I do that, I'd like to head over to Conjur. So I have a node port set up for the Conjur cluster. This will allow me to log in, and we can see that any activity that's actually happening outside in terms of consuming followers is reflected within the Conjur UI. So here's the Conjur UI. Here's the appdb password that I spoke about. So if I list down our secrets, here's the test appdb password, right? So actually, the test application is in the background, and I'd used it a little bit, but you can see the audit log that Conjur provides immediately, right? You can see that the host that is actually grabbing the secret, every time that it tries to read the secret, there is an audit event. So we have some visibility into access. Anytime that there's failed updates or like failed reads, we can see all of that. But right now I'm gonna go ahead and actually go to that application. So the application is running in HTTP. So I have to create a port forwarding using Kubernetes port forwarding so that the service test app is actually available through localhost for me. And how I can do that is by, I run this, and this needs to happen within the right namespace. So, sorry, so let's see projects. This is it, and okay, great. So that's running on localhost for me. And if I head over to localhost 1234 and I refresh this, you can actually see that it's handling connections from my laptop. And it grabs the secret value. Like this is actually the secret value. And if we head over to the Conjur UI and we refresh, we should see that there was an access. There was a. Hopefully, I'm on the right one. Test out the password. Okay. Well, in any case, we've just accessed the secret value. What I can do additionally is show how easy it is to then carry out rotation, right? So we have a script here that I can run, which is db rotate password. So it's a rotate db password. And what this will do is this will issue commands against the Conjur master, and it will modify the value of the password. So if we just go back and recall that the password that we were accessing is 5fcd, etc. I'm going to go ahead and modify this password. And this should be relatively fast. It will spit out whatever the value of the password here is, because it's just an environment variable that I'm creating here. So this is the new value. And you can see that rotation works right out of the bag, because if I refresh this, well, it won't work because I've just killed my port forwarding. But if I port forward again and I refresh, you can see that we now have the new value. And that's rotation right out of the bag. Let me see, I would like to refresh and just see. Oh, right, yeah. So now you can see that the audit log has updated. So 2 minutes ago, I made that modification. Like I read the secret, right, by going to the route. About a minute ago, I actually modified the password, and you can see that admin was allowed to update here. And then a second ago, when I accessed the secret value, you can see that there's another audit log. So yeah, that's the flow in a nutshell. I guess just to reiterate it, you deploy Conjur within OpenShift, and your application just kind of needs to follow a little bit of configuration based on docs that we've provided on this website here. We have example manifest. We have this example repo, which is publicly available on GitHub, and you can actually get up and running with this relatively easy. Right. I think that's about it from the demo side of things.
Well, that was great, and I totally blew my mind with the rotation stuff there. That was new to me. So really, thank you very much for the demo and for explaining how it all works. I'm looking to see if there's any questions in the Q&A, and right now mostly it's a lot of this is new to me. So I'm thinking what I'm trying to figure out how to phrase this question that someone's asking is like, what is the best practice around deployment, and whether or not the whole Conjur solution can run inside of OpenShift. And I think the answer for that, from my perspective, is yes, that's totally feasible, but I'm wondering whether that's the best practice or not. And I'm not sure whether Naama is asking me or asking it out loud so that she can answer that question. And if she unmutes herself.
No, I think that, no, I was asking for, I think this is something we can emphasize, that yes, Conjur can run entirely inside OpenShift. And the best practice, Kombi, you want to talk about that? Having it running on like the standbys on different nodes?
Yeah, definitely. So I guess what you want from your high availability setup is some disaster recovery, right? So if a node goes down within your OpenShift cluster, you want it to be the case that you don't lose all your data. That would be problematic. So what you want is, as you deploy a Conjur cluster, for example, you want it so that at least like your standbys need to be distributed in different nodes, right? So that if one node goes down, then one of the standbys can essentially become the master. Alternatively, if you're not doing everything within OpenShift, it's also possible for you to have a standby running outside of OpenShift, right? And still be speaking to the rest of the cluster.
Cool. So there's one other question around the sidecars. Do the sidecars need to call a specific follower?
Oh, what was that? Was that the question?
Yeah, that's another question.
Oh, okay. So the sidecar doesn't need to call a specific follower. So you can have 10 followers, and you just need to have a load balancer in front of them, and the Conjur deploy scripts that are available on GitHub actually show you how to kind of put all that together. And essentially, what happens is you need to then point the application pods or the sidecar to the service URL or the path within OpenShift, right? And the load balancing would do the whole like round robin going from follower to follower. So you definitely don't need to point to a specific follower.
Okay. All right. And now
yes, I think it's important to say that, because the followers here, there can be multiple followers. This is for scaling, right? For if there are many containers you need to support, right? On when they go up, so you need many followers maybe, and it's important that it's very flexible and you can scale very easily, and you don't need to call a specific follower, right? This is a very easy and scalable architecture.
And there's one more question that just came in: is how many pods can a single authenticator support?
Oh, okay. How many? So when you say authenticator, are they speaking about an authenticator running within a follower?
How well you want to?
Yes.
Follower.
I think, yeah.
The follower.
Oh, okay. I don't know the number off the top of my head, but that's something that we can definitely find out and probably.
I can check that
after, yeah.
Yeah, it's the same number for. I can check that, but it's like we have recommendation for followers in general. So it's how many requests per second a follower can support. This is translated into that number, and I can check the number.
Okay. And do you have one more slide there that's coming that has how to contact you, or perhaps go back to that other slide where all the references are? So as we end on this, people can see where to go to get more information.
We didn't add this slide. I can add that into the deck that we will share with you.
You had one slide that came at the end that was sort of where all your references were. And that was, I'll pull that from the slide deck and add that into the links from that into the video.
Okay. I think this is like the last slide. I'm just looking through the deck right now. There isn't anything specific with details about Conjur, but people can definitely head over to conjur.org, or alternatively, there is developer.conjur.net, which goes into, I guess, detail about the integration.
That's probably the best place to get started.
Yes, I can prepare a slide with a link for the docs and for the how to get started, like contact docs, get the docs, contact us, support PMs if needed.
That would be perfect, and I'll add that in.
I can add that.
All right. Well, I think that's all of the questions that we had in the chat. If there's anything else either of you would like to add, we're definitely going to have to get a follow-up on this to get a couple more, perhaps one of the folks that's actually using it in production to give a presentation on how that's working for them. That's what we like to do once we've got the basic information here, and have you guys back again soon.
Right.
Hopefully you are coming, or we'll have some sort of presence at Red Hat Summit or at one of the upcoming KubeCons, and we'll get to meet you all in person. And we're really actually excited about this stuff because it's really cool, and I think it's going to really help a lot of people. So thanks, guys, and I will post this up on blog.openshift.com and on our YouTube channel shortly, and we'll get the information out to you. So thanks for taking the time.